All right. And we are back live. If those in the online chat would be so kind as to leave a comment, that would be absolutely wonderful. I know. What they told us, and I think I described this the other day to you guys, how they said that they had ordered a replacement piece and it was defective. I told you all that. So what then they told us after the fact was, listen, everybody in C-Wing, hey, we got those things in the hallways. It's trying to cool you guys off. Just keep your doors open and keep your windows open. What are you doing? That's a little puzzle. Go ahead. Don't take it apart though. Anyway, so to keep your windows open, blah, 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 blah. And it's like, and you'll be fine. And I'm like, no, we're not. It's been like, it's, my goodness. Like Wednesday wasn't as bad as this, right? I mean, it was bad, but it wasn't as bad as this. Just saying. Not right away. I won't be able to do it today. No, I just don't have the time to do it right now. I mean, she can try, but I got work to do. Anyway. Okay. Here is the deal for today. Just so everyone in the chat is aware, at noon, when we hit that intervention period, I am going to be setting you guys off on today's task. And today's task is the post assessment for that particular standard. Now, I want to be very clear about the post assessment for that particular standard. You remember the previous post and pre-assessment, all that stuff? Remember how many questions they are? It's like 6 questions. Okay, now listen, it's not due today. I want to be very clear about that. It's not due today. I made it due for Wednesday because obviously people have a lot of stuff going on and I don't want you to rush through those problems. Yes, it's 6 problems and all that stuff. And yes, clearly you could just randomly click and then just click submit at the end. Yay, happy days. But I want you to take your time. It's not due until Wednesday. I'll be able to remind you on Tuesday if you did not get it done already. But obviously this post assessment does need to get done. I will make the link live at noon when we hit that intervention period. It will be through a Google Classroom assignment, and you'll have all the information you need to get that thing done on that Linkit test taker. Yay. Cool. In regards to today, I'm going to be continuing what we started with sequences and series. I'm going to give you a reminder as to what we did the other day in class, and build upon that information. It's going to be fantastic. Cool. You guys remember next week is only a 3-day week, right? Yeah. Then you got a 5-day weekend. Yes. I only have you on Tuesday of next week. But then the week we get back, I have you again on the 1st, and I have you then on the 3rd. And those days, for the most part, we will be reviewing June 1st and June 3rd. And then you will be taking your, and possibly a little bit again on like the 7th and the 9th, of course. But we will be taking our final exam on Friday, the 11th. So just make sure that you guys are aware of that date and you keep it in the backs of your mind. The final exam will be Friday, June 11th. And yes, it will be on Linkit. Yay, I know you're so excited about Linkit. Okay, cool. In the meantime, ladies and gentlemen, like I said, noon, we'll be knocking out that post assessment. I'll be making that live. But until then, if you do not already have them out, I'm going to need those notebooks out and open. Have you not listened to anything I've said since September? Ugh. That makes me sad. But then I got over it just as quickly. I'm sorry.
Well, no, I'm sorry. It's your fault.
Today is May 21st. We're going to call this sequences / series continued. It's just a puzzle where all the pieces fit together into the nice little cube.
That's it?
Yeah, I know. You sound so sarcastic for one who can't put the pieces back.
I can't.
Yeah.
That's why it was sarcastic. You made it sound easy. I couldn't do it. It was like, wow, that's all you have to do.
Yeah. Yeah. It's like the Rubik's Cube. Here, check it out. It's like the Rubik's Cube here. Is that right? I could do just some basic things on the Rubik's Cube, and it looks like I've only changed a few pieces. But it may look very simple from an outside perspective,
It's extremely difficult.
but it's difficult if you don't know the precise movements as to what is needed in order to get this thing done.
Well, unfortunately, I do not know the exact.
Anyway, here's a reminder for your notes. And I'm going to put this as a reminder in your notes because I want you to be able to practice a few different things that I'm going to be throwing at you. Again, just another reminder to those in the chat. If you have joined us a little bit later, please leave that comment. That would be absolutely wonderful. Just bringing up the chat right now on my phone so that I can see what's going on. There we go. I got you all right there. What's this? It's ugh, goodness gracious. Okay, sorry. Got an email from a supervisor that now I have to reply to. Oh, it's in regards to advanced placement statistics summer math. No, absolutely nothing for you to worry about. It's more for me to worry about. So the arithmetic rule. Last class, we went over the details as to what the general rule was for an arithmetic sequence. And I want to write it down again and get a little bit of practice with this thing because we are going to be using it and building upon this information. So I'm going to put this in red right here. Now, to be very clear, when it comes to these formulas that I'm going to be throwing at you, you do not have to memorize these formulas. I believe I said that the other day. You do not need to memorize these formulas, but you have to be familiar enough with them to know how to use them. So they will be provided for you so you won't have a typo in writing it, but you got to know how to use it. A sub n is just simply the notation for determining the term at any given point. You could do the 5th term, the 10th term, the billionth term. It doesn't matter. Whatever number you plug in for n, that's what we get. A sub 1 would be whatever the first term is, and d would be the common difference. Give me a single digit number. Give me a single digit number, but don't use 1.
8.
Okay. Give me another single digit number.
9.
Okay, we're going to do that then. So here is an arithmetic sequence using those two numbers. ... Where you told me 8. So I made that my first term. And then you told me 9. So I made that my common difference. This is the rule. Hold on, announcement.
Excuse the interruption. All paraprofessionals will meet in the library at 1:50 for a very brief meeting with Chip Junker. Again, all paraprofessionals will meet in the library at 1:50 for a very brief meeting with Chip Junker.
My mom was a paraprofessional. A paraprofessional are typically the assistant teachers who work with the special needs children. Yeah. She worked in the elementary schools for 26 years. Anyway. All right. So we're looking at this thing. I'm going to have to figure out a general rule for it. So I take that information, that first term, that common difference, and I throw it into the arithmetic rule formula. So A sub n equals 8 plus parentheses n minus 1 times 9. I just put those numbers in the proper location. And all I would have to do then is to simplify this stuff. Distribute the 9. Combine some like terms. And now I have the general rule for any term that I want, which is wonderful. So for example, if I wanted the fifth term, if I just wanted the fifth term, I would just plug in a 5 into that n, do the calculation, and it would give me the fifth term in the sequence. If I wanted the 10th term, I would just plug in a 10, and it would spit out the 10th term in a sequence. Great, fantastic, wonderful. Question. Yes. Okay. Question. What is the sum, and listen very carefully, what is the sum of the first two terms? What is the sum of the first two terms? You can do that in your head. The sum.
8.
Yeah, of the first two terms. 25. Yeah. Yay, we did it. Cool. Fantastic. Wonderful. Now listen very, very, very carefully. I ask you what is the sum of the first two terms, and yeah, it's just very simple. Just add 8 and 17. That's the sum of the first two terms. But what if I asked you to find the sum of the first 200 terms? Okay, explain why. Why would that seem like an extreme request? Yes, but for what reason though? What would you have to do first? Like theoretically, don't actually do it, but theoretically, what you'd have to find all 200 numbers. Yes, which now theoretically, it seems possible that you could if you had the time. Yeah. For example, like 8, and then there's 17, and then there's 26 and 35, and I'd have to find 200 of them. Like I'd have to find a bunch of those, right?
That was maybe only 25.
Exactly. That might have only been like 25 of them. Yeah. But then after I found them, I would have to add them all up, right? Oh my gosh. What a ridiculous request. Good thing I have another formula for you. Again, a formula that you don't have to memorize, but you have to know how to use. This is the sum of a finite arithmetic series. This formula that I'm about to give you is for the sum of a finite arithmetic series. First of all, when I say finite, I mean the opposite of what? What is the opposite of finite? Yeah, infinite, basically.
Infinite or
I guess it depends on like what tense you're using. If you're talking about the concept of infinity, that's not really a number. That's just like a concept of the largest, just keep going forever. You're heading towards infinity. But when I talk about the infinite, it's more like an adjective.
Okay, if we have time, I want you to watch this video and explain it to me, okay?
I need more context than that.
It's like it has something to do with like an infinite amount of something, but like it didn't actually. The problem really didn't make that much sense.
About rice on a chessboard. Oh, okay.
It's about a hotel room. It was like if there's an infinite amount of rooms.
Yes, infinite amount of rooms. Everybody, like every room is filled, but then you ask everybody from an odd numbered room to like move over, like whatever. You know what I'm saying?
Yeah.
Yeah, I know that. You'd have an infinite amount of space and stuff like that, right?
Yeah.
Yeah, infinity is not a number though. It's a concept. It's an abstract concept to wrap your head around.
So technically, it's made up.
No, it's not made up. It's an abstract concept that human minds in general haven't been able to wrap their heads around. Just because you can't understand something doesn't mean it's made up.
Just because you don't understand English doesn't mean it's made up.
No, English is made up. Mathematics exists outside the human mind. Mathematics exists whether or not human beings are here to appreciate it or not. But if human beings were not here, the English language would not exist.
Do you believe
Do I believe in aliens? You have to be more specific with your definition.
Do you believe in that there's another form of life out there?
There has been proven to be other forms of life out there. They have found microbials from meteorites that came from other planets. Microbials are technically life. Microbials are like microscopic entities. Like, have you ever seen like images where they like zoom in really, 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 really close at your eyebrows and you see the little bugs crawling? Those are microbials.
Yeah, there's bugs in our eyebrows.
Yeah.
That's why, did you know technically our eyelashes prevent them from falling into our eyeballs?
I don't know about that, but I'm just saying that there are on your bodies right now. So, and you can't get them off. Anyway, back to this. The sum of a finite arithmetic series comes down to the following wonderful formula.
Why did you shave them off?
Trust me, even if you tried to shave as much as you could, there would still be microscopic hairs on your body.
Okay.
Yeah. Would equal the following calculation. So this formula right here, which I'm also going to put a little box around in red. Like I said, it's not something that you have to memorize. This formula would be given to you when it comes to any form of an assessment, especially your final exam, but you just have to know how to use it. Now, for example, the S is just taking the place of the word sum, the sum of. The little subscript of N represents how many terms I'm asking you to add up. The little A sub 1 represents your first term. And this A sub N, well, we're about to see what this thing represents in just a moment. Now, just for the sake of argument, how many terms did I actually ask you to add up in the previous example? How many terms did I ask y'all to add up in the previous example? The one that we had the discussion about why it wasn't feasible. 200, yeah. So I want you to find the sum of the first 200 terms of 8, 17, 26, 35, ... I want to find the sum of the first 200 terms of that particular sequence. Now, with this, I'm going to be using that formula that I have at the very top of the screen. And first, I'm going to write it like this. Look how I just wrote that. I'm going to move this up just a tiny bit right here. Here we go. S sub 200. That N represents the number of terms that I'm attempting to add up. So whatever number you plug in for that N is how many terms they're asking for. So instead of this N in the formula, I'm going to have a 200 sitting outside these parentheses. Now, inside the parentheses, just for a moment, I'm going to write A sub 1 plus A sub 200. And I'm going to walk up to the board. Now, initially, in the formula, it's A sub 1. I'm leaving it as A sub 1. I know what A sub 1 is. I got to move it out of the glare for them. Here we go. I know what A sub 1 is. A sub 1 is 8. Fantastic. What the heck is A sub 200? A sub 200. What term is that in the sequence? A sub 1 is the first term. What's A sub 200? The 200th term. Do you know what it is, though? I guess I got to go back to the calculator and hit enter a bunch more times. You already know the cool way to find it. He said you were sleeping.
I know, I was really tired, okay? I can't always be the hyper person I want to be, okay?
Look what's at the top of the screen. Right there. This formula will get you any term in the sequence you want. And if we need the 200th term, all we have to do is plug in.
Can you put it open with your hand?
Oh, which part?
Yeah, there.
This whole part?
No, just the part where you're pointing to. Actually, it's fine. I'll just do it. You're good.
I got you. Well, I'll keep it here for a moment and I'll monologue like any evil genius. If you're trying to find any term in the sequence, like I said before, you want to find the 10th term, plug in a 10. You want to find the billionth term, plug in a billion. But if you want to find the 200th term, and I'll do my little note down here, a sub 200, I'm going to plug a 200 into that formula. So let me scroll this thing back up. And look what I did on the right side of that page. On the right side of that page, right here, I wanted to find the 200th term. And to find that 200th term, I simply used that formula and plugged in a 200 in for the n value. That gives me 1800 minus 1, or the number 1799. That's what I have to plug into this formula right here. First term plus last term, the whole thing over 2. Going back to our infinity conversation, which, by the way, I still have to get this answer, but going back to our infinity conversation, do you recall elementary school where kids would have arguments where, like, one would go, uh-huh, and the other would go, nuh-uh? Do you remember elementary school?
Yes. Are you ready for it? Let's reenact it. Mm-hmm.
Wait, so you guys did this, like, yesterday?
More like 2 days ago.
2 days ago? No, but then in elementary school, you'd go like, nuh-uh times infinity. And the other person would go, nuh-uh times infinity plus 1, right?
And then since I was a smart ass, I'd go, no, infinity's infinity. You can't add anything to it.
No, you really can't. You can't do calculations like that with infinity. You can't. Which is why this is for a finite arithmetic sequence. You can't add up an infinite arithmetic sequence. Now, there is a way, depending on the type of sequence that you have, there actually is a way to add up an infinite number of numbers and get something. Did you know that? It really is messed up.
Repeat that.
There is a way to add up an infinite number of numbers and get an actual number as the answer. After I get this answer, I'm going to show it to you visually.
Oh, that's because this is why I hate math.
What's up?
It doesn't make any sense in my head. You'll pull out an equation. It'll be like something, and there's either this exponent or a times 2 or a times something, and then that number makes a big number, even if you don't have a big number to begin with. It's too stressful.
Well, the visual example that I have does involve numbers, but you'll see what I mean in just a moment. But just for the sake of argument, look how I did that calculation. Ladies and gentlemen, look how I did that calculation. First, I did the 8 plus 1799. I did that separately. I divided it by 2, and then I multiplied it by that 200. I wanted to make sure that I did it precisely like that because I don't like typing this whole thing in at once. But Maddie, that formula, not formula, those numbers you gave me at the beginning, remember I asked for 2 numbers, you said 8 and 9? If you added up the first 200 terms of your sequence, you would get the number 180,700. That's pretty insane.
Yeah, that actually is.
Yeah, things tend to add up in that thing. It's nuts. Now, I have a couple of examples that I would like to go over with arithmetic, but I want to talk about this infinite number of numbers thing. Check this out. Arithmetic sequences follow the rule where you either add or subtract the same number every single time. There is another type of sequence known as geometric. Now check this out. How many feet would you say I'm away from that door, give or take? Is this about like,
12, 13.
I'm going to go with 16 to be safe. You know why? It's a power of 2.
Okay.
Yeah, I may have done this example before, but I want to do it again just for the sake of argument. Let's say I'm 16 feet away from that door. I'm going to walk half the distance and then stop. Yeah, but let's talk about that. Let's talk about that because there actually is a really nice way of calculating that answer.
I don't remember if you do
That's okay. I will. If I walk half the distance and stop, how far have I walked? 8 feet. Now, if I walk half the distance and stop again, here, I'll kind of draw a visual right here. Here's the full 16 feet, right? I've walked half the distance and stopped. There's 8 feet that I've traveled.
Then 4, then 2.
I know. But that's my point, though.
Oh, and then it just never stops.
If I walk half the distance and stop, if I walk half the distance and stop, if I walk half the distance and stop, I can walk half the distance and stop, 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 half the distance and stop. Theoretically, wouldn't it go on forever?
Yeah.
Now think about this. This is really going to mess with your brains. This is going to mess with your brains.
Is it?
Imagine for just one moment that I could take an infinite number of steps. Now, clearly I can't, but imagine that I could. If I could walk an infinite number of steps, do you know what the total distance of this sequence would be? If I could walk an infinite number of steps, I would cover the entire distance and I would walk a grand total of 16 feet. It's really messed up. Remember what I said before? I'm adding up an infinite number of numbers and getting a concrete answer. It's really.
So the reason that makes sense is because we have the concrete answer to the
Be that as it may, even if you don't have the concrete answer, there actually is like a nice little formula for it.
Exactly. That's where I get
Yeah.
confused because we have the concrete answer and we can do, oh, well, how do we get the concrete answer?
Mhm.
This is what you have to do to get it. That makes sense. When you give me a formula and then say,
The formula is a means to an end. Like the formula is to help expedite the process. For example, if I have to walk from here to Tom's River, or let's just say I have to travel. If I have to travel from here to Tom's River, it just makes sense. Like, oh, you could just easily just walk. It's like, oh, well, here's a teleportation machine. Oh, now you're giving me a formula for this? But the teleportation machine will just get you right there. It's like, nah, I'd rather walk. That's what it kind of feels like sometimes. Formulas are a means to an end, unless you want to see how the formulas were discovered. That would take a couple of hours. Yeah.
how does your brain process this so easily?
It's not that it processes it so easily, it's that I'm making everything up.
Honestly, you could literally tell me that it's a fake number and I believe it.
Okay.
I just trust every word that comes out of your mouth.
I don't believe that.
I do.
Here's a couple of examples that I want to try with you guys. First of all, imagine this sequence right here. -4, -2, 0, 2, and 4. It'll focus in a moment. There it is. And my directions to you are to find the general rule. When I say find the general rule, I'm simply asking for the equation that I can use to get any term I want. But then, same example, I want you to find the sum of the first, give me a two-digit number. Two-digit number.
69.
Okay? Of the first 69 terms. Now, I'm using the exact same sequence, so I'm actually going to put that right there. But this is a two-part problem. Number one, I want to find the general rule.
What's new?
Well, that's the pattern.
Okay, what's the rule?
The rule would be the equation that allows me to find any term in the sequence.
Okay, show me how.
Well, do you remember this formula that I put up as a reminder at the beginning of class? Well, I'm just saying, I put it in here. I won't take it away just yet, but see, I put it in a red box at the beginning. Oh, keep it right there.
Yeah, I remember.
Okay, good. This is how we find the general rule. Now, yeah, you can tell me +2, but +2 isn't really going to help when I say, okay, now find the 1,000th term. Oh, well, how many times do I have to +2? Well, if you had the actual rule, there's a difference between the rule and the pattern.
Well,
Go ahead.
the 1,000.
Look what I just plugged in here. Instead of a sub 1, I put in -4. Instead of d, I put in 2.
And why did you put 2?
Well, because you told me that the pattern was 2.
Okay.
Because the common difference was +2 every time. That's actually where that 2 goes. I got to simplify this junk. And if I simplified it correctly, I'm just going to skip a step right here. If I simplified it correctly by distributing and combining like terms, then ultimately I would find the general rule in that little box right there. Yes, the pattern is +2. However, the general rule is 2n minus 6. So now, for example, just for the sake of argument, you tell me, what is the fourth term? The fourth term in that sequence? It's 2. It's right there. Right? You can just it's right there. Well, hold on 1 second before we get to the 1,000th. Then I can plug in a 4 right here. If I plug a 4 right in there, 2 times 4 is 8, minus 6 is 2. It gives me the fourth term. Now, if you want the 1,000th term, you plug in a 1,000. 2 times 1,000 is 2,000, minus 6, 1994.
Wow. So pretty much you didn't have to do all that. You just use common sense.
Well, the formula. Now, the formula isn't necessarily common sense. The formula isn't necessarily common sense, but it can be incredibly helpful. For example, I don't know exactly how to build a car myself, but I know how to use it. I may not understand all of the inner workings as to how a car moves. I have a general sense of an idea. But if I was forced to fix something that's critical on my own, I don't think I could do it. But I do know how a car runs. Now, this formula, you may not know exactly how this formula came to be. You may not be able to create this formula yourself from scratch. But using this formula is in your best interest. But now I go to the next example. Find the sum of the first 69 terms. In order to do that, get your camera ready. You need that other formula right here. Oh, I thought you were going to take a picture of that. Oh, you are. There it is. I didn't see it. Yeah. For the sum of a finite arithmetic series, we need to plug in the number of terms that we're adding, the first term in the sequence, the last term, or for our example, the 69th term, divided by 2.
Yeah. I sleep through one class and I miss everything.
You missed me tap dancing too. You guys remember that? That was great. 4 years of ballet.
Yeah. I actually heard that. I thought I heard tapping.
I'm sure.
I thought it was in my dream.
Well, in order to find the sum of the first 69 terms, I am going to be, I need the 69 right there for the value of n. I need the first term, which is -4. I'm going to leave a blank there temporarily and divide the whole thing by 2. Now, keep in mind, I left a blank right there. I left a blank there because now I need the 69th term. I need the last term. But the only way that I'm going to get that, which is by using this formula. I'm sorry, I shouldn't say the only way. Clearly, I could do this. I could just do this if I wanted to. 2, 3, 4, 5, 6, 7, 8, 9, 10. I could go all the way up to the 69th term. Probably not. I'm sorry. Well, you know what? If you can get it before I tap all the way to the 69th term, so I'll race you. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's it, but I'll double check. I might be wrong because I was tapping kind of like randomly. It was 2n minus 6. So 2 times 69 minus 6. I was off by 1. It's 132. That's why using that formula is so much nicer. Because then I don't have to guess how many times I've hit it, and it gets very repetitive and redundant. But instead, I use the formula and jump straight to what I need, which is 132, which is the 69th term. And knowing that it's the 69th term, I can do the following calculation. -4 plus 132 divided by 2 times 69. 4416. Tapping it out that many times is not very helpful. Being able to use that formula to get to the 69th term, that is what is helpful. With every single one of these sequences that I'm going to be teaching you, it's basically going to be like, okay, here's the general rule. How can we use the general rule to answer the following question? Oh, we need the 69th term. Let's use the formula, plug in a 69, see what ends up happening. Oh, I got 132. And then I just have to calculate that out correctly.
I went to Taco Bell yesterday and did a Baja Blast and Joe's birthday.
Joe Sanchez?
Yeah.
Okay.
I was like, I go, is that Joe? In person? It was honestly an astronomical experience.
It's really funny. The Taco Bells that you guys have today are so much nicer than the Taco Bells from 20 years ago. Just, well, when I say so much nicer, I mean, like, it almost feels like they're trying to be fine dining. Yeah, 20 years ago, not the case. Okay. Yes. Why?
Joe, I was telling them about how I saw you at Taco Bell
I could have
yesterday.
told him that.
But it means more for me.
Okay, okay.
Okay, bye, Joe. I love you. Look.
Yep, there he is. Just bye-bye. All right. Now, we are going to be getting more practice with arithmetic sequences, but I also wanted to give you a definition and a couple of formulas for geometric. These are the only two types of sequences and series that we're really going to be putting our interest in. We're only really going to be focusing on arithmetic and geometric. It's more of an introduction to what sequences and series are all about. For an arithmetic sequence, that is a sequence that has a common difference. That is arithmetic. Arithmetic sequences have a common difference where you add or subtract the same number each time. In geometric, a geometric sequence is a sequence with a common ratio, or you multiply/divide by the same number each time. This is the pure definition as to what it means to be a geometric sequence. You have to multiply or divide by the same number each time. So, for example, give me a single digit number.
8.
Okay. And give me another single digit number. 3. So 8, 24, 72, 216, ... That is a geometric sequence. Because I asked for a number, you told me 8, and I made that my first term, a sub 1. I asked for another number. You guys gave me 3. So I multiplied by 3 each and every time. Now you're surprised by 216. But this thing does tend to escalate quickly, very quickly. Do you know what would come after 216? $648. And then 1944, and then 5832, and then 17,496. Oh, after 216 would be 648. You're just multiplying by 3 every time. But instead of worrying about it, I would actually just get myself a general rule. The general rule for this particular sequence, for this example, is 8 times 3 to the n minus 1 power. That's all that it is. That's the general rule for this example. I'm going to give you the formula for it in just a moment, but I wanted to take this in and kind of give you a warning, very much a warning for this particular problem. Now, just for the sake of argument, if I wanted to, let's say, we know the second term is 24, right? Clearly the second term is 24. If the second term is 24, I'd plug a 2 in. 2 minus 1 is 1. 3 to the first power is 3. Times 8 is 24. Or if I wanted to find the third term, I'd plug a 3 in. 3 minus 1 is 2. 3 squared is 9. 9 times 8 is 72. This general rule governs this whole sequence. Do not multiply the 8 and the 3 together. Tell me what comes first in PEMDAS, multiplication or exponents? Which means you have to evaluate 3 to the power first and then multiply by 8. Do not make that a 24. Don't. If you do, it will be wrong. I know. Still governs our lives. Here's the general rule that you do need to know how to use. The general rule for geometric. It's very similar to the general rule for arithmetic. It just has different operations. A sub n equals a sub 1 times r to the n minus 1 power. This is the general rule for geometric sequences. It still has a sub 1 there, meaning the first term. It still has n minus 1 in the problem, except it's now in the exponent spot. And of course, there's no common difference this time. There's only a common ratio. There's only a common ratio. So we do have to be aware of that. One more example and one more formula, and we should be good for today. Let me try this. I'm going to scoot this up a bit. I have an example that I want to show you. Scoot that right there. Okay, here's an example. I have the number 512, 256, 128, 64, ... There's an example right there. You can prove to me that you understand what the pattern is if you can tell me what the next number is. What is the next number in this sequence? Can I give you one small hint, though? 32. It is 32. Here's the one small hint. It is geometric. meaning they are multiplying and dividing by the same number each time. If the next number is indeed 32, then what is the pattern? Dividing by 2. But now here's the issue. I would not say that the common ratio is dividing by 2. I couldn't write that. I couldn't do that. Instead, if I'm going to divide by 2, I'm going to say that my common ratio is actually the number 1/2. Because each time it gets halved. And then if I'm going to use this general rule up top to write this formula out, oh no, every class. A sub n equals my first term times the ratio to the n minus 1 power. And this would be that general rule that I would use. You don't actually have to simplify that at all. You can just leave it right as is. There's nothing you can do to simplify it at the moment. Well, technically, but I'm going to leave it as is. Writing out the general rule for geometric is a lot nicer because there's not as much stuff to do for it. Now, if I asked, hey guys, what's the sum of the first 4 terms? You would probably respond, why, Mr. Markey, you just have to add up the first 4 numbers. Let me get a calculator for that. Cool. And then we'd have an answer and we'd have a good old laugh about it. If I said add up the first 4 terms. But again, what if I asked for you to add up the first 400 terms? I know, right? If only there was a formula. And there is. Not for a geometric. Oh, my goodness gracious. No, the formula that you took a picture of earlier, that was for the sum of an arithmetic. It has to be an arithmetic sequence in order for that formula to work. And that's what? Arithmetic sequences, you were either adding or subtracting the same number every time, and this one's multiplying or dividing. Yes. No, you're absolutely correct. You're absolutely correct. But that is the key difference between this. That's the key understanding factor in understanding these problems. One of them is adding, subtracting. The other one is multiplying, dividing. Here comes that formula. Now, we're not going to use this today, but I want to make sure that we have it written down. Sum of a finite geometric series. Sum of a finite geometric series. The formula is slightly more complicated. Again, I am not expecting you to memorize this like I have, but you are going to be expected to know how to use it. It equals the following calculation. The sum of the first however many numbers, n, is equal to, well, a sub 1, which is whatever your first term was, times the fraction 1 minus r to the nth power, r again being that common ratio, n being the number of terms that you're adding up, divided by 1 minus r. Now, I'm not going to write this one out. I'm actually going to do this one in the calculator, but I want to show you something in the calculator in just a few moments. Just giving people an opportunity to write this down. I'll zoom in a tiny bit more. Sum of a finite geometric series. Again, you won't be expected to memorize it, but you got to know how to use it. So, for example, in the previous problem that I gave you, if I just said, hey, add up the first 4 terms, I'd be like, okay, 512, 256, 128, and 64. They add up to the number 960. But check out this ridiculous calculation that I'm about to do right here. Check out this ridiculous calculation. Ish. Yeah, okay. 512 parentheses 1 minus 0.5, bless you, to the fourth power. I'm doing 0.5 because it's easier instead of doing 1/2, divided by parentheses 1 minus 0.5. If I did that ridiculous calculation right there, look what number it also spits out. The exact same number, the exact same sum. The formula works. It's just that you have to know how to use it correctly. You have to know how to use it correctly. It's really messed up when you're going back and forth between positive and negative numbers, but I'm not going to get into those details right now. That's for another day. Okay. We are about to transition to the intervention period for today. So for those of you in this classroom, if you do not already have the Chromebooks out and open, I would strongly suggest that you do, so that we can transition to this post-assessment that I'm about to basically give you. Boom. Yeah, real quick. We gotta get this done. So on your Google Classroom, I just posted this assignment. It's very similar structure to the other post-assessment that you guys took, which, as a side note, you guys did very well as a class on the other post-assessment. You did very well. It was like 85% or better. This one's going to be slightly more difficult. But like I said, notice the due date. You have until May 26th to get that thing done, which is fantastic. But you're going to click that test taker. You're going to put in the code that I provide for you right there. Access it. You find your name. Your password is your student ID number. And there are 6 questions. Now, here's the deal. It's not due till Wednesday, meaning if you leave the test taker, if you close that out and then come back, it will still be there. It will save everything that you did up to that point. But I want to make sure that you have enough time to do it. Mr. Markey, can I just submit the thing before I leave here today? Yes, you could. You absolutely could. I'm just saying you don't have to. I am not forcing you to. It's not due till Wednesday. So please take your time with these problems. Joe, if you do have a question about that, email me, and I can answer that separately. So definitely email me your question, and I can answer you via email in a little bit. Sorry, there was a question in the chat that I just wanted to address. It'll still be live. It'll still be live. With quizzes, I don't have the option of like opening the code back up because I'd have to pay money to access the site. But with Edge Elastic, I set it specifically for what they call manual close, which means it won't close until I do it. Yeah. So you guys have the remainder of the class period to get this done, 12:22. Let's get moving. Yes.
There was sticky stuff all over the bathroom floor, so now my feet.
I'm sorry. For you two guys that just came back in though, just so you know, the Google Classroom has the assignment that I posted. It has the code and the directions for you to complete.
I know, I saw all in the bathroom.
Well, there you go.
It just happened.
Somebody's too excited on a Friday.
Oh, I'm so sorry, I didn't do that. I'm trying to just.
Sorry.
I didn't want squeaky shoes anymore.
I'm sorry.
I said I didn't want squeaky shoes anymore.
I know. I said I'm sorry.
It's okay. Somebody's really jamming out right now.
Mhm.
I might have to ask them to turn it down a little bit. It's distracting my education. Mr. Murphy, why is this scribbled all purple?
I don't know. I was out one day and somebody did that.
Can I erase it?
Sure.
It's been there the whole year. Pretty much the whole year. This is what I like to see. Somebody who takes care of the whiteboard. These are facilities. Do you love wings?
Sorry, what?
I said, do you love wings?
They keep giving me things. The Wing Tour USA people. Yeah. So far, I've gotten the sunglasses. I've gotten the magnet. They also got me a chicken wing bow tie.
Aww.
Yeah.
Did you wear it to school yet?
No.
You should.
Maybe on a Tuesday.
Why on Tuesday?
Because Tuesdays are bow tie Tuesday. Since forever. I'm doing bow tie Tuesday every Tuesday for the past like 8 years.
Really?
Yeah.
You always wear a bow tie on Tuesday?
Yeah. Have you never noticed?
No.
Please tell me someone else has noticed.
Yeah.
Thank you.
Of course he noticed.
Gosh,
But you also did point out at the beginning of the year.
that's true.
You were,
Gold
you guys
star.
Were lucky because the days you guys come in
Uh-huh.
are Tuesdays and Thursdays, so you get to come in and see what I do.
That's true.
Oh, you're right. I do faintly remember that. Wait, what did you say?
You told us at the beginning of the year that we were lucky because we have Tuesdays and Thursdays, so you can see them on bow tie Tuesday.
See, Chris gets a good job sticker.
I'm being pranked right now, right?
There you go.
Yeah.
Yeah.
No, you're not allowed. Yeah. Be careful before you Of course it's Mr. Liston's room, right? What's your favorite color, Mr. Markey?
Blue.
Well, that's unfortunate. You don't have any blues, so.
Sorry.
Really, I feel like you'd be an orange kind of guy.
Yeah.
Yeah.
Yeah, yeah, yeah.
Mr. Markey, you're a junior, right?
Yes.
What's your first name? James?
Yes.
James Markey Jr.
Yep.
Want to know something funny?
What's up?
My dad's name is James.
Uh-huh.
Do
So
you
is
go
my
by-
son's. And so is my dad's.
Do you go by Jim?
No.
Do you go by, so just James?
Yeah.
Of course you do.
Why are you surprised? Or not surprised?
Because you're the kind of guy that's like, where it's like, if somebody was like, oh, do you have any nicknames? You'd be like, no,
Correct.
call me James.
Correct.
Just like that in that voice.
Very much so.
Oh my God, Mr. Murphy, why don't you use any of these beautiful markers?
Open one up and you'll see. Exactly. They got. I ordered. I ordered the wrong size. And it yeah, that's what happened. So
Oh my god. That's outrageous.
it is.
That is outrageous. I feel bad. They're all witches?
Yes. Except for maybe like the black ones. Yeah.
This is a normal one? I have a feeling this is.
You can see them on the side, actually. Look. It says ultrafine.
Mr. Marky Bro. Of course, that's something that would happen to you.
Yep. Same thing happened with masking tape that I ordered one year.
Oh my god.
Yeah. Got the wrong size.
Do you have a ruler by chance?
Yeah, I got plenty of rulers. I think they're in that back closet though.
This one?
Yeah. I think. If they're not there, then I have no idea. Anything? I don't know what that is.
Okay. Can I just use tape then?
Tape?
Hmm?
Tape? Sure.
Use it as a straight.
All right.
That's to make your board pretty.
How's everybody gonna know your name?
The dragon spewing fire in the letters of my name outside the classroom door.
What if they don't see it?
How do they not see it?
I don't know, because I look at it every single day. How's your kids?
They're there.
Okay. How's your wife?
She's there.
How's your dad?
You know my dad?
You'd be surprised. I know lots of dads.
Now, if you knew my dad, you would never forget.
No, I kind of have a thing for dads.
This conversation went off the rails.
I'm kidding, Mr. Markey.
Anyone else agree?
Yeah.
Justin, I feel like you have a hot dad.
What?
I don't know. Just the way you present yourself, I feel like your dad is like rich.
Congratulations.
No, I can't.
What would you guys do in this class without me? Huh? What'd you say, Scott? Probably learn. I just make learning a little bit more. I'm sorry if you guys feel that way. I'll stop doing it hard. I know, but I don't want to disrupt your learning process. I think if anything, I make it a little bit more. Mr. Mark.
Yeah?
Oh, I'm just saying your name a little bit sad.
This post-assessment is not due until Wednesday. Trying to give people a bit more time to get it done.
Can I borrow this?
Why?
Would you guys like to see Mr. Markey's name that I put on the board? I made it pretty. I made it. Oh, is there? I made it pretty so people know who he is. I'm just gonna turn it anyway, even if you guys don't care, because I think it's just beneficial. I can also sing a song for you if you guys would like. Mr. Markey. Mr. Markey. You said good job. Oh, Joe, what an angel.
What am I gonna say? What would you want me to say? Oh, say. The what? You know what I'm talking about? How did it go? I don't want to say it. Hang on, you're fine. Bro, I think Sean Equal. Oh, that one. Have you ever seen one? We are castaways. What's another one? Oh, I know one. Can't take it. I actually saw a really funny one, and Mr. Markey, I think you'd appreciate this actually, because it's kind of funny. He was like, yeah, my daughter got this new app where like you do cute little like dances and stuff, and she keeps singing me all these songs. And then he like dresses up as his daughter, and he's like, ready, daddy, watch this. And she goes, can't take it. Oh, I saw it. We know it's like our parents when like they were like showing their mama songs and it was like a little song, and then us when we're like, you wanna see the song? It was like, wanna see the dance I learned? Yeah, that's exactly what I and then they go, ready? Can't take things. Oh, say. Did they hear it? All I heard was one kid hear it. We can have a constant room. Is your class always like this, even when Corona wasn't a thing?
Huh?
Is your class always like this, even when Corona wasn't a thing?
Always like what?
Like, all you do is sit there and talk?
No.
Did you do fun activities?
I was able to do a lot more things.
I heard you drop kick the door.
I do a lot. I was able to do a lot more things, mainly because I could have you guys move about the room and be in groups, and I was able to, go from group to group and to be able to do these things, whether it be like group activities or group competitions or things of that nature. COVID has really limited the number of things that I am allowed to do.
Yeah, it sucks.
Next year.
It's wrong.
Okay. Next year, my hope is that things will get back to some semblance of normality, and that I'm actually able to do the things that I typically do. Oh, sorry, this thing broke off.
He's a cheater.
It's a centerpiece. The
He
center.
cheats.
You don't understand Rubik's cube.
No, I do.
Centers-
The
centers
center doesn't
don't move. There we go.
You're trying to dance and everything.
It's me first.
Oh my god, you haven't. I know, I noticed that before I started college. Let me out.
I knew. 20. And we're halfway through the 21st.
You really do this every single day?
Not every day. He almost forgot today. If it wasn't for me, he wouldn't have done it.
We are castaways.
I can't even solve one side on a Rubik's Cube.
Oh, Mr. Markey. James did this?
Yep.
He's not trying to be an artist when he told her, right?
That was from like 2 years ago.
Oh.
He drew that when he was like 4 or 5 years old.
Oh, so now he's good. Like, what is that?
He's considerably a lot better now than he's 7.
What's the problem? 1 plus
Maybe it's a flamingo.
2010.
Nose, it's pink.
1 plus 2010. Was it 2010?
2011.
Just saying, he's a bit better than that now.
Mr. Murphy, I wasn't judging him. I was just
I
making
think you were.
I'm just
I
joking.
think you were judging an elementary school student's ability to draw and really express himself.
and everything.
Oh, wait. Is that a cat teacher?
Yes. It definitely is.
I just want to know what that is.
It's a flamingo. That is 100%. Like, look at the nose and the eyes, and it's pink, and it's like swirly. You know how they like make themselves like healthier, more like swirly.
Did he write that or did you?
I'm not certain.
That's kind of neat.
Good.
I don't recall writing
That's
it.
neat for a
But,
4-year-old.
but like also like this numbers, they're good. Like it's a good drawing, but I'm gonna make fun of it.
Because you're mad. Because I'm mad.
Anyway,
If he was here though, I'd hug him and tell
all
him
right,
how good it was.
and that is the day. We'll see you all next week.
Bye everybody.